Today we are looking at Pascal's triangle and binomial expansion. Pascal's triangle is just a triangular array of numbers, and we form each row by starting with a 1, ending with a 1, and then the numbers in between come from adding the two numbers directly above it. So as you can see here, we start with a 1, end with a 1. In the next row, we start with a 1, we add those two ones together to get 2, and then we end with a 1. So you can kind of see from this animation over here. We start with our shell of 1s, and then we add the 1 and 1 together to get 2, add the 2 and 1 together to get to 3, and just keep following that pattern. So we can use Pascal's triangle then to help us with binomial expansion, just basically taking a binomial to a power. Typically, if I wanted to find something like x plus 3 to the fourth, I would have to take x plus 3 times x plus 3 times x plus 3 times x plus 3, FOIL the first two together, collect your like terms, multiply it by the third x plus 3, distribute, FOIL, collect your like terms, then take that answer, multiply it by the fourth x plus 3, which is a really long process. Binomial expansion lets us use Pascal's triangle to shorten that a little bit, make it a little bit easier for us. So to do that, if I want to take that x plus 3 to the fourth power, I'm going to create a table. In the top row of that table, I'm going to put the row from Pascal's triangle that matches our degree. So if we want the fourth degree, we're going to take the fourth row. Going back to Pascal's triangle, just be careful. The top row is row 0, row 1, row 2, row 3, row 4. So the one we are working with would be 1, 4, 6, 4, and 1. So that's going to go in the top of our table. The second row, we're going to take the first part of the binomial, which in our case is x, and we're going to start with that to the fourth degree. So that's what goes first. And then we just go down 1 degree as we move to the right. So x to the third, x squared, x to the first, and then x to the 0 power, which we don't need to put. We're going to do the same thing on the bottom row, but we're going to start on the right, and we use the second part of the binomial, which in this case is 3. So 3 to the fourth, 3 to the third, 3 squared, 3 to the first, 3 to the 0. Your last step then is to multiply the column together. So the first column will give you the first part of your answer. So it's 1 times x to the fourth times 1, which is just x to the fourth. 4 times x to the third times 3 is 12x cubed. 6 times x squared times 3 squared, which is 9, gives us 54x squared. 4 times x times 3 cubed, which is 27. And then 1 times 3 to the fourth. That will give you each term for your final answer. One thing to be careful on is if any part has more than one part to it, like this second part here has 2 and a y, you need to make sure that you're taking the powers to both of those. So in that bottom row, we go 2y to the fifth. Make sure you take 2 and y both to the fifth to get your answer. Looking at an example on your IXLs, they won't always ask for the entire thing. They might just ask for part of it. Typically, I think it's going to be easier, though, just to work out the whole problem. So in this case, I have v plus w to the fourth. So since my degree is 4, my top row needs to be that fourth row of Pascal's triangle, which is 1, 4, 6, 4, 1. My second row then will be my first term, which is v raised to the fourth power. There we go. And then I just want to fill in the rest of the row by taking the power down 1 each time. So v to the third, v squared, v to the first, and then v to the 0, which is just 1. You don't have to write anything there if you don't want to. Then we take our second term, and starting on the right, we just work backwards, doing the same thing. So we want to do w to the fourth, and decrease the power, w to the third, squared, w to the first, and then 1. Last thing then would be to multiply these together. So that first one would just give me 1v to the fourth. Second one then would be 4v cubed w. Easiest thing to type out. And then just keep going down there. For our part, that's the only two things I needed was 1v to the fourth and then 4v cubed w. We can see that we get 6v squared w squared, multiplying this one together, 4v w cubed, and then 1 w to the fourth. Hope this helps. As always, please reach out through email or Flipgrid if you have any questions as you work.